Hello, are you in need of virtually clean, limitless energy? Is your society in need of some wasteful energy to combat climate change? Well, boy oh boy, do we have a solution for you. Nuclear fusion. Now you may be asking us, what is nuclear fusion? To answer that, we will let our product manager, Awan Mayasekaras, speak on the topic. Nuclear fusion is the process in which the nuclei of atoms combine or fuse together to form different atoms. It is a process that releases a large amount of energy and is typically found within the cores of stars. However, before we tackle any of that, it may be helpful to learn the parts of an atom. The atom consists of two things, the nucleus and electrons. Within the nucleus are protons and neutrons. Protons have a positive charge and neutrons have a negative charge. So when they're combined into the nucleus, they have a positive charge. The number of protons defines what each element is, while the neutrons are also part of the nucleus but can create one more thing, isotopes. An isotope is a variation of an atom with a different amount of neutrons than what it should normally have. For example, hydrogen normally has 1 proton and 0 neutrons, but an isotope of hydrogen, called deuterium, has 1 extra neutron. With that background knowledge covered, we can now properly understand fusion. You might be thinking, nuclear fusion is really easy. I take one atom, I take another atom, and then I smash! However, it's not always as simple as that. When you attempt to force the two atoms together, you have to face the Coulomb barrier. Because both of the nuclei of atoms are positively charged, they will repel each other. There are two possible ways to overcome this repulsion, enough heat or enough pressure. If you are still a big fan of crushing atoms together, just apply enough pressure, and you eventually force the nuclei of the atoms close enough to form a reaction. Another method would be to heat up the atoms to ridiculous temperatures, till the atoms turn into plasma. Plasma is a state of matter where the electrons wander away from the nuclei, allowing the nuclei to easily hit each other and start the process of nuclear fusion. Let's take one of the simplest fusion reactions, the fusion of hydrogen into helium. Hydrogen is the simplest element of the periodic table, consisting of 1 proton and 1 electron. If we fuse a hydrogen nucleus with another hydrogen nucleus, we get what is called deuterium, which is an isotope of hydrogen containing 1 neutron and 1 proton. Now you may be wondering, how on earth did that neutron get there? Am I just really high? No, you are not. Probably. When the two nuclei collide, a process called beta decay occurs, in which the proton decays into a neutron and some other subatomic particles. Remember that in this plasma, there are multiple hydrogen nuclei floating around ready to be fused. If hydrogen fuses with deuterium, it forms helium-3, with 2 protons and 1 neutron. However, we aren't done yet. We are looking for helium-4, containing 2 neutrons and 2 protons. Speeding through the process, 2 helium-3s make beryllium-6, containing 4 protons and 2 neutrons, and since beryllium-6 is unstable, it will lose 2 protons to form helium-3. Essentially, helium-3 combines into a bigger atom, which splits into smaller atoms, which forms helium-4. You might be wondering where all of that promised energy comes from. Atoms have something called nuclear binding energy. This is the energy that holds the nuclei of atoms together. As atoms are breaking and splitting apart during fusion, the nuclei are arranged, and all that binding energy has to go somewhere. It can't just disappear. So this tremendous amount of energy is released outwards into space, making it an exothermic reaction. I thought you were gonna talk about stars. Oh right, I forgot. Stars in the universe often contain a lot of hydrogen, due to it being the most common element, and they fuse hydrogen into, you guessed it, helium. This released energy in the form of radiation balances out the force of gravity the star exerts on itself, trying to pull it in. When these forces are in balance, the star does fine.
Hey, boss? We have a small problem. Well, what is it? Don't waste my time. We appear to have run out of hydrogen, sir. Ah, don't worry. Just use some helium. No one will ever know.
And that's exactly what happens. When stars run out of hydrogen, they begin to fuse helium, and then heavier elements. This process starts spiraling, going from hydrogen to helium, to carbon, to oxygen, to neon, to magnesium, to silicon, all of which produce energy to counteract gravity. Then we reach iron. Unlike the other elements, iron doesn't produce energy, but rather requires energy, making it endothermic. Now the star can no longer produce energy to balance out the force of gravity. This causes what we know as a supernova, which also produces a lot of energy, but that's a story for another time. Well, there you have it, folks. Our revolutionary product has the power of a star, perfect for your gaming PCs. Thanks for tuning in.